search code. Now this is easy, right? This is a small program. There's nothing to this, right? It's not very long. How many lines? 24 lines. No biggie, right? Well, try thousands and tens of thousands of lines of code or hundreds of pieces of code. I mean, right now we're dealing with one program. This is just one file. This one's called hello2.java. But as we get our projects going, we're going to be doing multiple files too. You're going to be having different files with Java. And like I said, some of them will be running the program and some will be extra class files. So we'll be doing all that stuff. But a big part of doing some of this, if you see on the left side, is organization, knowing where your files are, things like that. And like I said last week, the suggestion I had is find some place where you want to put your files, wherever it is. Like under my documents directory, I had a folder called develop. You don't have to do this, you can do whatever you want. Now you'll notice I've got a whole bunch of stuff. Some people organize their stuff by their class they take. They say, I'm taking Java Program 1, I'm going to create a Java Program 1 folder. Okay, that's fine. So you just do new folder, Java Program 1, like that, right? So now I've got it. And then inside there, I would then put whatever I had. And some people break it down further. They say, okay, you know what? I'm going to do this. I want to do each week. Week 1, week 2, week 3. Then you know. So if there's ever an issue or something like that, or hey, I remember in this week we did this, you can go right to that code really easy. The nice thing about this also is sometimes is that when you zip it, I showed you, you can just right click on that folder, which is what you want. Because when we're in this, we're going to start doing stuff. So actually what I'm going to do for right now is I'm going to do week 2 for what we're doing here. We'll do week 2. So, and if I'm going to be a good boy, I'm going to try and remember to do some of that stuff in there. I'm going to leave that open, work on that. Let me pause this for 1 second. Okay, so using data. Like I said, I won't stick with this. We're just going to use this as guidelines, chapter 2. Getting in some of the types. These are a lot of these types are similar in other languages. So again, if this is let me ask you this. So for those of you, this is your first programming language. Java is a great language. Like I said, it's very flexible. Once you learn this language and the style and syntax, you can carry it over to a lot of languages. It's very C-like and PHP-like. Java, like I said, is one of the most popular languages out there. And once you learn how to code in any language, not just Java, it's pretty much about syntax and semantic and just trying to, okay, this is how you do it. So I can do a variable in language like this, but in another language, it's a little bit different. That's it. And then you're just learning these little nuances between the languages. That's all you're doing. So if someone goes to you and says, well, do you know how to, well, I have some experience. This is what we say. You can't know everything, right? So when I would always like interview for jobs or stuff like that, if I didn't have a lot of experience in the language, like I was learning PHP, I'd say, you know what? I've coded in Java, I've coded in this, and I have some exposure to PHP, right? But I'm learning it. And they're like, okay, but you know Java, you know all that stuff, right? So they figure that you'll be able to do it. That's what they're looking for. Looking for people who can learn languages, can write code, have an understanding of that, versus someone who comes in off the street. Because there are people that will come in who've never programmed before, and they'll do it, but they just might not get it. It happens. Or you might hate it. Like I said, I've had students who are really good at programming, and they don't like it. And what do you do? There's nothing you can do. The idea is to do something and hopefully love it. Like I said, you're going to be sitting or whatever at your job, wherever you are, 8-10 hours a day, maybe doing stuff. Eventually, yeah, we all get sick of what we do. But I mean, I love to code. I love to create stuff. I love to write stuff. I love to fix problems, solve problems, figure stuff out. So anyway, I digress. So different data types. We've got integer types, booleans, characters, floating types, and we're going to go through each one of these. And then we get input from the user using something called scanner. It's at the keyboard, and then JOption pane is a graphical alternative. And then we were talking about constants earlier. So a constant is a variable. The thing about constant, just like it says, it can't be changed. Okay, you cannot change it. What would you use? What would be an ideal constant you'd probably use in a program, something in math? How about pi? 3.14159. You're not going to change that, right? So if you have a program that you're going to use, you could create a variable called pi, set pi equal, and like pi equals 3.14159, however many digits you want to go to, and do that. I had a friend who was running a race, and it was pi. The length was pi. It was like on pi day, and the distance was on pi, and they would have pi afterwards. I mean, it was like pi overkill. And I didn't do it, but I was thinking about that. You know, pi is infinite. It doesn't really end, right? Or does it? I don't know how many digits are. So if you're running a race, it's the distance of pi. Do you ever stop running? I know it's just sorry. I think they stopped at 3.14. I think they did. I'm not sure. Anyway, see, I have just all right. Little constants, again, values, numeric constants, again, so you can do different constants. You can have letters, you can use like states, numbers, all that kinds of stuff. What a variable is just a location in memory. Your computer has a memory. The RAM in it, it's sitting in here. You've got the hard drive and you've got the memory sticks. The more memory you have, so like when you say, oh, I've got a 1 terabyte hard drive and I've got like 16 gig of RAM. The RAM is what makes these programs run faster and they can run in memory. So you can run like Microsoft Office or applications in your office or whatever the case may be. Those are great. So it's that memory where these variables are stored. So when you run a program, when you're running your email program or your browser or whatever you're doing, you play music or whatever it is, it's using memory up. So the more things you have open, now I've got, this is people pick on me about my tabs. I have a couple tabs open here. Just a couple. I always have stuff going on, and so I don't like to close stuff. But anyway, so it uses that memory, and it threads and it says, hey, okay, you're doing this, you're doing this, you're doing this. And that's what these variables. So a variable will store this value. So I have a value like pi, or I want to store birthday, right? What's the birth date, or your age, or zip code, or anything like that, your driver's license. So you can put that in a variable. Why would you do that? Because you want to make changes to it, or you want to use it later on. You log into a system. What do you do when you log into any system? What does it always ask you for? User ID and a password, right? Everywhere. So those are variables that are in the system that are usually system-wide. So as you travel throughout the system, it says, oh, it checks. Oh, do you have access? Oh, Chris logged into the system. What access does he have? These are variables that are passed around. And usually those are called global variables is what they're called because they're available all over the place because you need them like that. That's what that is. And then you have a data type is what kind of data is it? And we'll talk more about that. I'll go back for a second. Data types, Booleans, characters, floating points. Integers and floating points are very similar. Integer is a number, 0, 1, 2, 3, 4, 5. Floating point is a decimal. That's all that is. And again, we'll go through more detail on this stuff. So I just kind of give you a heads up. So don't be overwhelmed by a lot of this stuff. We will go in a lot more detail with a lot of this stuff. Primitive data types is a simple data type, which we'll detail. So here you go. So here's kind of your primitive data types in Java. You got bytes, shorts, ints, longs. The ones that are kind of stick together, as you can probably see, are the short, the int, and the long. And well, the float, and then the float and the double kind of go together. And then you've got a char or char. It depends what your char stands for character. So some people say it's char. I say char. It's just how I am. However you say it, you're not wrong. And then Boolean is true or false. That's it. Booleans are great flags. Access permitted to a system. Are you is administrator? I'm going to create a flag to get into a system. Are you administrator? True or false? False. Don't give access to certain screens, certain areas of the system. Every system has something like that. You have to decide when you're coding as a developer when to use certain things. Most of the things you can get away with using a regular integer, even a short integer. And that just means on memory space. We're so spoiled now. We've got so much memory that we can do all kinds of things and it really doesn't matter. So you could like have everything be like a long, or you could do a double for double precision. It's just, allows you to have the number that big. For us, for the average person, it makes no difference whatsoever. If you work for NASA, you work for another agency where you have precision, like they have to have precision. You become a programmer on the stock market, you need certain precision of your numbers. Then you're going to be concerned with how you write code, and you'll see it because they want precision up to a certain level, maybe 5 decimal points. I don't know. It just depends on the program. That's when that comes into play. Let's do this. Hang on a second. Let me pause this record this. So we're going to jump into, we're going to do the You Do It on page 58 together. So I'm going to go into JGrasp. I'm going to do File, New, Java, like so. So I'm going to have my empty program. There's nothing there. It's empty. I can use my control key. I keep doing this to make it bigger so you can see it easier, and use my mouse wheel to go bigger or smaller, is what I'm doing. You can do whatever you want to make your size. You can change the whole environment, different colors on that. Notice everything is a class. We talked about that before. So the first thing I'm going to do is say public class, and this is data demo. And they always have you do open curly and then close curly brace. And I'm a huge Three Stooges fan, so I always make the noise. I won't do that to you and drive you crazy because I do it a lot and my students get kind of tired of it. We're going to run this as a program. So typically with everything, you start your class off. This is data demo, and we're going to have a main method. So we're going to use the boilerplate public static void main. And we'll talk about all these arguments too later. So string. And we'll also talk about why string is an uppercase. Args. Open curly, close curly. Okay. I'm going to reinforce this a bunch of times too. So right now we've started typing code. I like to save my code pretty quickly. I don't want to lose it. So you can do Control S if you want. That's kind of what I do. Control S to save it. When it's the first time, we talked about this last week. You remember the class is called data demo. By default, that's the file name. That's what you want to stick with. You don't want to change it. So whatever you call the class, the file name has to match. If you have an issue with it, you'll get errors that come up. And I can show you how to do that, creating errors like that. So I'm going to leave it, and I'm going to hit save. Now I'm going to overwrite mine. Users won't get this because I already have mine because I've done this several times. And you'll save it. I'm going to come up here inside the main method. Now you'll notice also, I haven't talked about this a lot, especially for new developers, white space is good. You want to have white space. It makes no difference to the compiler, to the interpreter when it goes through and it builds your program. This is for us as developers so we can see it better. And I also do the indentation. I'm tabbing over to get that space there. Anytime I have a method, a class, whatever it is, I always like in the inside, I will always tab. I use my tab key. I tab over so it's like that. And if I have another one below here, I'll keep it then in line with this one. If I do something inside now, which I'm going to do, I tab inside there. So I'm indenting. It just kind of breaks it up. And we're going to create a variable it's an int variable, and it's called a whole number. Very exciting. And we're going to assign it a value of 315. And that's how you do it. So int stands for integer. This can be anything you want, a whole number, and then you set it equal to a value. Now this is what the book has. I don't like this, the way they do this. It's not really old school. It's the way I learned, and it's the way a lot of people code. When I create a variable, I like to put something in it that you can kind of look at it and right away you know what data type is. So I changed that A to an I for an integer. Doesn't mean you have to do it. You can do whatever you want, literally, because you're creating that variable. You just created that variable in memory. I like it because if I'm looking at this and all I see is this, because I'll see this somewhere else in my code, and I'll see the variable I whole number, I'll know right away that this is an integer. Okay, it may or may not help me debugging code later on, but it's just something to know. It makes my life easier. So I'm going to do that. So I'm going to say int I whole number is equal to 315. Okay. And then all they want to do is they're going to spit it out. So they're going to use that system.out.print. Now they're going to use the print first, which means that it's going to type something out and it's going to keep the cursor on the same line. Okay. So we'll just say the number, I'll do quote, the number is space quote. And every line except the methods, not the methods, but every line ends with a semicolon, typically. So system.out.print. So it's going to print this line out, and then the cursor is going to sit there, and then I'm going to print out another line here, system.out.println. That's an L, lowercase l. And I'm going to actually put that variable in here. Here's another thing. I'm lazy, and I make mistakes. I'm just going to copy the variable, Control C, and paste it down here, Control V, without the space. For a couple of reasons. One, it speeds my process up if I'm able to do it because it's right there. Another reason is I don't mistype it. I can't tell you how many bugs are created by developers, especially new programmers and developers. And I use those terms interchangeably because they are. That will mistype that. They'll do a lowercase w or a lowercase n. It's sensitive. So if you whatever you type, it's got to be exactly the same for that variable to match. And I'll play with it. So we've saved this as data demo. Okay. Now let's just run it. I can click on the plus key at the top, the plus button at the top. It's going to build it. Notice it's compiling. So it's using the Java JDK, which we didn't talk about a lot last week. So when you install JGrasp, and these systems all have it, typically what you have to do first is you install the Java Java, it's the SDK, it's the JDK, Java Development Kit. That has all the libraries, that have everything it needs to develop, and it's got files like this, the Java C file. All JGrasp is a GUI, a graphical interface allowing you to create these programs, and then it calls this. It calls Java C -G, it's a little flag, and then your program. You can go to a command line outside, and I'll show you how to do that, and you can type the exact same thing to build it. JGrasp is nice because it does it for you. All you do is compile. And then when I run it, I click on my little runner guy at the top. It calls Java, which is another executable Java program, space, and the name of the program, data demo. And then it ran it. And it gives me my output. The number is 315. Now let's do this. Well, let me stop for a second. A lot of programmers will do this too. They will put at the end of the curly brace a comment / end main method. It's tedious and extra, but again, imagine you've got all these different methods and codes and all this stuff, and now all of a sudden you know, oh, that's the one, that's the curly brace that ends this. Okay, I'm cool, that's cool, and then you can put one here / end class, and you might even want to do this, say the whole thing, because you could have multiple classes too. Anything that helps you as you go through, because again, when this, and I'll just do this. This is like, you know, how big this is. You're like going around, you're like, I missed it. Where's my curly brace? You know, obviously it wouldn't be that, but that would be all code in between there. So just things to think about. I'm not saying you have to do it this way. Really, you got to figure out what works best for you. It helps me. I'm a simple person. I just kind of helps me. Okay. Now, what I want to do is I'm going to leave everything, but I'm going to mistype something. I'm going to get rid of the I in whole number there. And I'm going to save this. I'm going to rebuild it. And it gives me an error. And it says system in a whole number variable is not found. It's kind of nice. So it tells me, it puts the arrow there. It says, oh, and then if I do, okay, I'll put the I. Now, what if I put that back? I compile it again. It worked because you're going to be doing a lot of debugging. What if I change this to a lowercase w? What will it do now? Let's compile it again. It doesn't like it. And this is what I'm telling you. You got to be careful. So watch your upper, lowercase, all that kind of stuff, whatever you do. And that's why I copy and pasted, just made my life easier. I'm like, it's the same thing. Oh, here's a fun one. This happens a lot. You're working with small code, and all of a sudden there's a space there. I had someone who substituted a 1 for an L. We couldn't figure out what the heck it was. Because you know, here, so you know, there, so I'll do it down here. So here's a 1, and here's an L. And it was that one mistake that it wouldn't build, it wouldn't run. It was driving us crazy. Because if you look at that, you're like, oh my gosh. And it becomes a nightmare. So goofy stuff like that. I'll put a space there, same thing. So just the things to think about as you go through, because you're going to do debugging, and the better you get debugging, the better you'll be at coding too, because you know how to plan for stuff. But then you'll see there, it says it can't find that variable. Well, what do you mean? It's right there. Oh. Again, if you're not sure, just copy, go back to where it was, and paste the sucker. Recompile. Now it works. There you go. Now we're golden. Okay. We got our exciting output. The number is 315. So very exciting. What I'm going to do is I'm going to back up a second. You don't have, you can follow me. We're going to put the just so we've done it together. But this is our demo, and you can include this in hand. So this is really the first one of your assignments. So data demo. If we go back to our homework, here it is, declaring and using a variable right here, data demo. Yay. Okay. And a lot of what we're going to do is we're going to copy and rebuild stuff off the other stuff. So, but let me do this. So what I'm going to do is, in order to use the JOption pane, you've got to import a library. And to do that, and all you do, and we'll use this data demo, so don't worry about it. I'm going to go to the top of it, and I'm going to enter a couple times. And when you import, you do it at the very top before you do the class, any of that stuff. And all you do is type import space Java X dot swing, and this one is dot J, capital J, capital O, P option, and then capital P again, JOption pane. And we'll get more into libraries and talking about the libraries and a lot of things like there's a lot more details with those, as you might guess. Everything else is fine. We're going to keep it really simple. I'm going to come down here below my system.outs. I can leave those print lines in there. I don't have to change any of those. I can leave them. I can do both the system outs. And I will tell you, I use system outs for debugging all the time. If I'm chasing a program and I want to see what the value of a variable is, that's one way you can do it. It'll show up down here below in your console. This is what you call your console. The JOption pane is typically to get the pop-up, and so that's what we're going to do. So the syntax for this is JOption pane dot show message dialog. Okay, JOption pane dot show message dialog is a method of the JOption pane class. Everything's class based. So JOption pane is a class. Show message dialog is one of the methods. And what are you doing? So left parenthesis, and did I mistype something? Did I not do that? JOption pane. No, I should be fine. Okay, we'll see. I don't know if I did something. The first parameter, and these are called parameters. So left parenthesis, null, and my null becomes purple. And we'll talk about what that is just kind of right now. And then what I'm going to do is I'm going to type something similar to what I just did. Say the number. So quote, the number is space, close quote. And then in Java, I want to do what's called, I want to concatenate or add something onto it. So I have a string that I'm going to put information in, and then I want to concatenate the value of a variable. In this case, it's the whole number. And guess what? I'm going to copy and paste. Like that. Just so I have it. And again, a semicolon. We're going to see if this will work or if I did something wrong. So this is standard. JOption pane.showMessage dialog is very standard, null. I have a string, the number is, and then I'm adding plus, so I'm concatenating. What am I concatenating? One whole number. Okay. Let's see if this builds. Yay, it built. So that means our code is correct. Whether or not the logic is correct, remember we talked about there's logic errors and programming. But let's do this. Let me run it. Okay. So below in the console, I get the number is 315, and I also get the pop-up. The number is 315. So it came up in both places. I had a student that was working on a game, and everything we did was console-based. It was down here below, and he didn't like that, and so he literally wrote the whole thing with the pop-ups, with the dialogues, which is fine, but it took a lot more work. But it was, it was kind of cool. So he built this whole game like that. But when we do stuff, it's kind of up to you how you want to do it, as long as you understand what's going on. But that's all you have to do for that. So this added a little bit more to this one, but I wanted you to get a taste of it. So that's your data demo. Any questions on that? Java from a front-end perspective is not the most sophisticated, I'll say. If you see other applications that are out there that have been built by different languages, Java is from the front end is it's okay. And you'll see as we go along, we'll do stuff. And they have you get really more into it in Java too, more into the graphical piece of it. But it's still, it's okay. Um, the reason it even as good as it is because they saw that the other languages were so much better at the graphics and the front end that they wanted to at least get up to a certain level of that. Typically, Java is used a lot more on the back end, server end, connecting to databases, creating what are called web services. And all web services is an application. It's talking to a server somewhere, getting something. Getting the weather information, that's a web service. I can use a program, I can call this web service that's sitting on a server and gives me the local weather. I send it a zip code and it sends me what the weather is like where I am. That's kind of the common thing there. So Java works really well on the back end for a lot of that stuff. Not to say again you can't use it on the front end for this GUI, but I think there's other languages potentially that are more robust. It depends. It just depends on what you're doing. But I just want to kind of let you know. So because a lot of the tools once you get into it, you'll be like, wow, this is kind of primitive in some respects. But it still has purpose. Okay. Ding, ding, ding. All right, so we're gonna, like I said, we're jumping around, doing some stuff. So we did assignment operator, declaring variables, assignment, and we did some of this stuff, right? We created integers, my age, your age, and that's what we did here. I created an int whole number. Okay. All right. All right. Let's do that. Tell you what. So let's do another one. I know. Oh wait. No. Yeah. Oh. Chinese. They actually have you do a couple of other things too. Interesting. Maybe do a lot of stuff to this one. Well, this is good. Let's do this anyway. They have you change, so we can do this. I'm going to create another variable. So I'm going to stay in this program. I'm going to create another variable. I'll create another int. I'll say I don't know, I'll say value. And I'm just going to do a semicolon. I'm not going to assign it anything. So I'm going to say int I value. That's it. And again, I'm sticking with my nomenclature of putting an I in front of it. And I'm going to compile it. No, it compiled fine. But now what I'm going to do is I'm going to go below I value and I'm going to say system.out.print line. And all I'm going to do is say print out I value like that. So system.out. I want to see what I value is. I didn't assign it anything. What's going to happen? Nobody knows. This is what I love about programming. You get questions. I get questions all the time from students, or I don't know myself, and they'll be like, "Well, what's going to happen?" I'm like, "I don't know. Let's try it. Write the code and let's try it." So there we go. So we're going to see how far we get. So I'm going to build it. Is it going to build? No, it won't even build. So I get an error. It says variable I value might not have been initialized right there. And then it points you right to it, which is kind of nice. So it even gives you a line number, line 12. You got to get used to reading these errors. So datademo.java 12 means line 12. Sometimes the line it points to might not be the exact line where the error is. Sometimes you have to look above. That might be where the error is. So it just depends on the situation. So system.out, it says it might not have been initialized. And you're like, oh. So if you do something as simple as this and set this equal to 0, then recompile it, guess what? It compiles fine. It does not like it when you try to use a variable that has not been initialized. That's a problem because it doesn't know what it is. It's just there's nothing there. It's not being used, so it blows up on you. Okay, and that's what they're talking about in the book on page 59. And then we'll do one more thing they have there too. Let's see. We're actually getting close to taking a break here. Jeez. They want you to create a constant. And the only difference with creating a constant is you actually use a word called final in front of it. And the final makes it a constant. And you can't change it. Once you create that, you can't change it. And so the book has used states because there are only 50 states. So that's not going to change. Or like I said, we can use pi. So let's use pi. We used that before. So I can do this. Pi, I'm going to use a double pi and set it equal to what? 3.14. Can do like that. Okay. And I'm going to come down here and I'm going to just print out pi. Instead of I value, I'm going to change my I value to pi, right there. So I've got a value, and it's not a constant right now. It's just that. So I'm going to compile this, make sure it builds. Again, and I get kind of anal. I do like to write a couple lines of code, and I compile to make sure everything runs okay. Let's run it. There you go. So I get pi 3.14 spits out. I get my old output, and I even get the pop-up. So all the other stuff still shows up. Okay. Now I'm going to come below here. Let's do this. And I'm going to change pi and say pi is equal to 3.14159. And then print it out. And see what happens. See if I get 3.14 or 3.14159. Let's compile it. I get no errors. It's cool. It likes it. Let's run it. And I get pi is 3.14159. So I assigned it. I initialized the variable as a double, which is basically a decimal. I assigned it the value of 3.14. And then the very next line, I then reassigned it to 3.14159, which is perfectly legal. I can do that. Okay, let's do one last thing here. And I'm going to put the word final in front of that. You notice it's purple or pink or whatever. Mine is like a pinkish, purplish color. So now I did final double pi is 3.14159. I'm going to try and compile it now. I get an error. Cannot assign a value to a final variable pi. So it goes to line 14. It says line 13. So line 13, boom, there you go. Pi, I can't do that. It says you knucklehead, you can't do that. You just said it's a final, it's a constant. You've assigned it. You can't reassign it. Make up your mind. What do you want? Is it a variable or is it a constant? Okay. All right, so maybe I'm not sure what I want to do, but I'm going to keep it as a constant for right now. So remember I told you about comments? So all I'll do is do // comment that line out. I won't delete it. I'll just comment it out, recompile. Yay, now it compiled, and now it runs, and everything's back to normal, and everything's good in the world. Now I can go eat my M&Ms and drink my Mountain Dew and be happy. Yeah, not a big fan of the PowerPoints, but they do serve a purpose. So we're talking about integers, name constant. We talked about the final, the constant, print and print line. I don't know if you noticed that with the print statements that I did. So the first one is the print, and then the second one had the print line. So it prints that first piece on one line, it leaves your cursor there, and it continues on. That's the only difference between those. Just remember. Again, it's just a formatting issue. That's all it is. It's just formatting. So JOption pane, we did that one. Yay, show information. Okay. So that's good. Let's see. Maybe they have a thing of the character data. We're talking about ints. Yeah, I may as well explain this too. All right, so you've got the int data type, integer, which is what we just used, and that's your value range from a negative to a positive of. I don't know if you read that, well, how big that number is. So this would be million, billion, 2 billion, the 2 million, 2 billion, 147,483,647. Positive and negative. That's an integer. So again, depending on the application you're doing and what you're doing, you have to decide what data type you need or want to use. And then variations of that I was talking about was the byte, the short, and the long. So again, depending, int is probably good for most of what you do. Sometimes I'll use a long to do something else. So again, the long just gives you that much more memory to do things with. Again, depends on the precision and how big your number is. But I mean, seriously, that's a big freaking number. I think if you're like doing a program where you're calculating budgets or salaries, I don't think you have to go bigger than that unless you're working for the federal government or something like that. And you're doing their budget. Then you probably have to do this. Then you probably have to do the negative one, right? Go the negative way. Anyway, so there you go. So here's all the different values in there. And again, you can see how they progress, the 30. So back in the early days, we had to really concern ourselves with memory. And so you're like, okay, let's use a variable as big as little as we need necessary. So you can go small, 32767 for the short. And there's nothing wrong with that. This is the issue comes in is if you go down the road and you start getting data that's bigger than you expected, then you've got to change the data type that it's going into. Remember the Y2K? You guys ever hear Y2K problem? I don't know. I know some of you are too young for that. So the issue was with Y2K was the mainframe, they only had space for 2 digits. So every time they did a year, 1986, they just did 86. 1992, they just did 92 because they only had space for 2 digits instead of 4 digits. Well, guess what happens when it went from 1999 to 2000, right? 99 goes to 00. Is that 1900? And then, so that's everybody was freaking out. And then the issue was utility systems, the electrical systems, all these systems were tied into it. And there were a lot of people were freaking out that it was going to shut down. So they spent years and years upgrading these systems to make sure. There were still hiccups, but it was not as bad as anyone expected it to be. But that's nowadays there's plenty of memory, but usually the best practice is 4 digits for everything you see it. And sometimes you'll even see date time stamp. You'll see the date and then actual a timestamp with it too. So we've got a lot of space, a lot of memory space. We're very spoiled. As programmers, we can be very sloppy because we can use up lots of memory and it's not really a big effective. Boolean, I mentioned the Boolean earlier, it's true false. And a lot of times you said Boolean if you go into an application of just whether or not someone is an administrator or did they log in correctly or something like that. And it's just a true false, that's all it is. It's really kind of a nice little thing. And you can create one and set it that way. And we'll use Booleans as well too. You also have the relational operators. Remember this from math. Something is equal, it's less than or greater than or equal. And the fun one with the exclamation mark and the equal is not equal to. And so they give you all these different examples. Again, and these PowerPoints are in the unit. I think this level, I can't remember if it's edition. So they're all different examples. A lot of times programming is math. A lot of people say I don't like the math. Well, there's math. There just is. And so a lot of times when you're solving a problem in programming, sometimes you just have to solve the math problem, and then you can do it. I'm working on a program right now in Python that is a mortgage calculation program, and it's just math. So I have to solve the math part to make sure I have that right, create the pseudocode to do that. Now we talked a little bit about pseudocode, and you get more into it, but you know what I was going to say? I think I kind of jumped ahead pretty quick with some of that. Did we talk much about it? I feel guilty that we kind of skipped over some of that. Let me do this. So pseudocode, pardon all my stuff. Notepad. Here's a really simple thing. Pseudocode is a simple way of writing something down when you're starting a program. And you use pseudocode to kind of just give you an idea of what you're doing. So here's the thing. Your boss comes to you and says, I want you to create a program that adds up 2 numbers and spits out the sum. Okay. So most of us as programmers and developers were like, okay, they start coding right away. It's like, no, slow down. Now this is a very simple example, but so the first thing you would do is you'd say what? Input number 1, right? Get me number 1. I'm going to add 2 numbers. I'm going to spit the result out. So I need numbers, right? So give me number 1. What else you need? Well, input number 2. What are you going to do then? I'm going to add them up. Add number 1 and notice I'm using just English. You can use some students will use some programming kind of stuff in there. I advise of making it too language specific, make it generic. Pseudocode is meant to be English, meant to be generic, so you can use it for any language. But the idea is that so anybody can look at this and say, oh, I see what you're doing. So input number one, or I don't even know if input, it could probably just say get. Because input's very much like, again, I'm thinking from computer terms. So get number one, get number two, add number one and number two. So pretty much any person should be able to get this. And then display result, right? Or show result. So that is pseudocode. That is the most basic pseudocode. You have a problem where you're trying to add up some numbers. Now you can complicate this and go to different levels, and you just say, okay, how do I, like I was just saying, get a mortgage rate, or get this, or get that. I can't sit still. Sorry. I was one of those kids that probably, if they had him at the time, the mom would give me like ADHD or whatever it was, but they didn't know what that was then. They didn't have that. They said, your kid's hyper. So, I want, and my wife hates me for that. So, but I also do exercise a lot too. So, anyway, so that's the idea. It's just you're getting numbers, you're doing this again. I can adjust this, and I can say something out, and then you could say, what if it's a program all of a sudden it's not just adding numbers and you want to find the one that's bigger than the other one? Well, then you could change it instead of adding them, right? I could put a little comment here. Not really a comment, but I was saying I could delete it and I could say, compare number one versus number two, and then display larger number. I mean, you get the idea. That's all it is. Again, I'm comparing. You want to break it down. A lot of times, new programmers and developers get really hung up in different things. And you call find the larger number. You ever heard the term KISS? Keep it simple. Keep it simple, stupid. Really is what it's. My stepdad used to say that to me all the time. He says because we do math. He was a math person. I actually got my degree in math, but you'd see some big formula and you figure out. Now, you guys remember from your math days? I know some of you are still probably taking math. Inside out, right? You get a problem with parentheses and all this stuff, and it looks crazy. Keep it simple. Break it down. Go to the inside out. You start the small one. You go inside, and you work your way out. And pretty soon, you're like, oh, this is really easy. If you break it down really simply, and that's what you're doing with coding, you're trying to keep it simple. Go step by step by step. And because what's going to happen is if you go too fast, you're going to, when you debug it, you're going to have to go step by step by step. So the idea is when you program and write the code, you don't have to go through a lot of that. But so this is in a nutshell, and the book talks about this, but this is so PSEU pseudocode is what this is. Typically, as you develop as a programmer, you don't get really into that, but you still kind of outline stuff. I've had developers plan stuff out. There's this one programmer I worked with, and he would plan and scheme and all this for like 80% of the time, and then he'd only write code 20% of the time, but his code was like dead on. He was good. Although one time he wrote this code which had these recursive loops in it, and he couldn't figure out what it was. They gave it to me to look at, and I'm looking at it, and I'm scratching my head. I'm like, his name was Jens, and I'm looking at it, and I go to Jens. I said, Jens, what did you do here? It took him 2 hours to figure out his own code. Because it did like this call. He was trying to be so efficient. See, there's good and bad then. There's trade-offs. You try to make it so super duper efficient and make it really cool and small. Because some developers are like, oh, you can't do all that. You got to put it on one line and make it really efficient. But if it takes you 2 hours to figure out what the heck you did, and I'm a simple man. I like to keep it simple programmer. Let me know. And that's why when I write code, my recommendation all the time, and I tell my students this, is just get it to work. Don't look about being fancy. It doesn't have to be pretty. It doesn't have to be this. Think about nuts and bolts. Think about pseudocode, how you do it. Just write it down, what you think to do. Okay, calculating this, figuring out numbers. I want to get this stuff out. Write it down and then go from there and then start writing the code then. and go from there. And then keep it simple, because if you keep it small pieces, I think it'll help you tremendously. That's just mine. Okay. I want to keep plowing through some of this stuff. Floating point numbers. So floating point numbers are just like it's got the decimal positions, right? Think about currency. Currency is the most common. Again, scientific research, anything like that, you need the decimal points for precision. It depends on what you need. I do a lot of races, and they're very much into the hundreds. He finished the race in 35.14 or something, right? For me, it makes a difference. So you have the float and the double, and we saw the different sizes of those, right? Did they show it there? It didn't show it there. They'll show it later. So there's a different size, and again, it just depends on the digits. Many years ago, back when I was, I think, I don't know, when I first started working, there's a size difference there. So one of the float is 4 bytes, and the double is 8 bytes, and there's a size. Intel came out with a math coprocessor, which went with the board, and it miscalculated. The calculations were inaccurate at the 10th or 8th decimal place. So for you and me doing budgeting, doing spreadsheets, that's probably not a problem. But for some actuaries, things like that, or you're doing some high-end financial transactions, any type of issue with it, they put a fix out pretty quick. But people figured it out. But it was like at the 8th decimal place that there was a problem with it. So if you were calculating pi, you would have had a problem. But the idea behind the math coprocessor, it's supposed to do your calculations that much faster. Okay. Char or care holds one letter. And the way you initialize is just like that. Char, my initial, like an M. We do that. And it holds one character. We're going to do kind of a funny one here. On page 73. So the char is one of the primitive data types. And this one we're going to do is we're going to do the char demo. Let's see here, because which one is it? How far? I know I'm kind of going, I got slowed down a little bit here. So let's go back to learning units. Let's go to unit 2. So data demo, integer demo. Okay, so we did data. Did we not do the integer demo? Did we miss that? We did that. Oh, we didn't do integer demo. All right, let's do integer demo. Char demo. So you'll have those two. All right, so we'll go back. We talked about that. All right. So we're going to do integer demo first. I can find my code. Okay, so file, new, Java. Again, I'm going to make my screen a little bit bigger. That's just for me. I mean, that's just for you so you can see it better. So public, again, public class. And this one, public class. And this one is integer demo. Like so. Open curly, close curly. Again, I'm going to tab over inside that class, and we're going to add our main method. You'll have this memorized. Public, static, void, main, string, left and right brace, args. Open curly, close curly. Okay, sorry. All right. I'm in here. I'm going to save it. Now watch your spelling. Some students don't spell that correctly, or the capitalization. Again, whatever you type it, that's what's going to be. So file, I'm going to Control S to save it. It's going to default in my Java directory. Integer. You know what I'm going to do? I was going to put it in my folder that I created, because didn't I create that folder for us? Week 2. You can do that if you want to in your folder, because that's what you're going to send to me. Save. Okay, so integer demo. So inside there, we're going to create some variables in the main method, okay? And they're going to create 4 different variables. So int. I may have you do int. I don't like that. I'm going to say int. I hate when they do that. Is equal to 12. Okay? The bytes. UITE. And I'm going to use a little b. And then byte. Again, that's just kind of the, because again, I can kind of see that. Short. SHORT space S. Shoot. Should I do that? It's gonna mess me up. Oh, I'll leave it as a short. Leave it as a short. Equal 12, semicolon, and then long a long is equal to 12. Okay. And then all they want you to do is just print them out and see what they look like. And then you're gonna play with a couple things with the conversion. So let's do that. So we're gonna do, we can copy and paste this stuff too. So system.out.println, and then they want to say the int is quotes plus. I'm gonna copy and paste mine. int. And then what I'm going to do is I'm going to just copy that whole line and paste it 3 more times. 1, 2, 3. Oh, of course I messed up. If you need to have something come back, you can go to the beginning of the line and do a shift tab, and it does a backwards tab. So tab goes one way, shift tab has you tab backwards. Shift tab. All right, so this is going to become byte. You learn all these little tricks when you start writing more code and you're sick of typing lots of stuff. And then long. So int, byte, short. And then this is going to be b byte. Again, I'm going to copy and paste so I don't mistype. Short, a short, and a long. Like so. And it's already saved. And I'm going to run this just to make sure everything, I'm going to compile it, make sure it compiled correctly. Didn't miss any semicolons, didn't miss anything. You want to make sure of that. So compile, and I'll run it. And very exciting, I get the output of each one is 12. Woohoo! All right, so we know this works. This spits out. So now they're saying go to the byte one and change the 12 to 1, 2, and now do 3, 4 like that. Just make it 1, 2, 3, 4. And then you're going to compile it. And it's going to give an error. Because it's going to be, and the book says, try to recompile it. It's too large to be placed in a byte variable. It's too big. Like, oh. And that's the thing you got to worry about. So you go back 1, 2. And that happens again. I'll recompile. I'll get rid of that. I'll put it back. It's okay. If I go to the short, I can go 1, 2, 3, 4, 5, 6, 7, 8, do that. Let's see. Will that work? No. Again, that's too much. If I go back a couple, am I okay there? And you can, if you're not sure, again, you can go look up the precision. So that's okay. That size of that variable is fine. So you really have to be careful when you start choosing variables if your values of what you're going to put in there get too bigger than you thought they would be. And that happens. It happens over time. It may not happen when you create the program, but as you're working on it, someone say, hey, you know what? We need to add this to that application. Can you do that? You're like, yeah, no problem. And then when you get into it, you realize if you add a certain data or piece or whatever the case may be is, zip codes. Here's one. So a zip code is for a string though, because 5, 3, like a zip code is usually 5 digits, but a lot of times you also add the extra 4 digits on the end, and it can be 9 digits. But if you're only expecting 5, you're like, oh, now I gotta make it bigger so it accepts the whole thing. And I mean, so things like that, I guess, is the best analogy I can make. So I'm not gonna have us go through all this right now because I want to get to the other one too. But if you have problems, let me know your problem. We can do a character in here. It's not exactly part of it, but here, I'm in here. I'll just create a char while I'm at it. What the heck? So I can do char, and I was going to use C. I use C for char, and just say C and value, and then set it equal to whatever you want. Uppercase, lowercase, it doesn't really matter. So say E. Oops, single tick like that. And then I can print it out below. System.out.println, C value equals C value. So if I compile that compiled, and if I run it, it gets my C value. Now, if I initialize the char, I know some of you are still typing, and I put another letter in there, like that, it doesn't like it. It changed the color. I'm going to put it again, and I'm going to see if it'll compile. And it's going to give me an error. Unclosed literal, it's like error. Warning, Will Robinson, warning. Okay? Because a char, by definition, is one character. So I can't do that. As soon as I do that, you notice it goes back to green. It goes to green. Yeah, it goes to green up there too. Like so. So things like that you got to watch out for. So like, oh, I need a couple things. A lot of times people use a char instead of a Boolean. They'll do a char for, they'll do something like this, or a flag, C flag. You don't have to type this. And they'll do an N. It'll be a Y or an N for yes or no for something. And they'll do that sometimes. So they'll just check this character to see if it's an N or a Y for yes or no. But a Boolean works the same way. So is one better than the other? No. Is there a best practice that tells you which way you should go? No. It's what you want to do. Just in case, part of the reason I tell you a lot of this stuff is because you may see it in code and you'll be like, well, why did they do that? Let me tell you a quick story. I worked for a company, a small company. At the time we were developing all applications, library software, very exciting, woohoo, right? All in with a language called Visual Basic. It's an older language, but it's still around. A lot of places use it, but it's basic with Visual, right? Every module, we had like 8 modules, 7 modules, were all developed in Visual Basic. Only one of them was developed in C++, Visual C++. Why? Because the person who knew it wanted to develop it in Visual C++, and they let him. Why? So they had the one, and then what happened? He left, and no one knew how to support it, except for me. I knew some C++, so I had to quickly learn. It was a nightmare. So that could happen. So be careful what you say. Hey, I know this, I know that, because they will give it to you. So let's just say that it was an off-budget project where I spent time converting this system administration module, which was in Visual C++, to Visual Basic. And again, the main reason was because the whole code base was Visual Basic, and we wanted to make it so that anybody else can code. You don't want to write something in a language that no one else knows, unless you are concerned about job security, but that's not the point. I mean, I worked for a company, and I wanted to make it so that I could go on vacation, or you could look at it, or you could look at it, anybody could look at it. If you all know the code, that's fine. And the company was just like, he wants to, let him develop what he wants to. That's fine. And it's just like they didn't realize. So anyway, I digress. So there you go. So you can spread out a flag, a char just like that. So then let's do the char demo on page 73. We'll do a new one here because I know we're starting to get short on time. Again, you're going to get so used to students. Public, class, char demo. And yeah, I know some of this is repetitive, and I do get that. It's just to get you used to both the structure of the program and just setting all these classes up. And then again, public, static, void main, string, args, open curly, close curly, like so. Okay, again, I hit Control S to save it, and by default, it's going to save char demo. Look at my file name, same thing, save it. And I already have it, but I'm just going to redo it. This is a unique one I kind of want to show you because you might run into this. This is kind of weird. So we're going to do a char or a char, whatever you want. And we're going to say it's A. You have a capital A in there. System.out.println, println, and they're going to print initial. Okay. So let's just run this and see if this works. Okay, we'll keep it simple right now. We built it. We'll compile it. Okay, it compiled below. Beautiful. And I'm going to run it. And I know I type probably a lot faster than some of you. Maybe not. I had students who could type like 90 words a minute. and they were like waiting for me constantly. And then I had some students who could only like my team lead, my former boss, he would hunt and peck. And he was a programmer. He'd be like, it took him a while. So anyway, so that works. So what did it do? It printed out the character A. Very exciting, I know. So now we're gonna do this crazy sequence of stuff. And I don't know if it was in PowerPoint, if it showed us. There's a bunch of characters. Let's see. You can print out a whole bunch of stuff. Escape sequences. So you can do new lines, but the escape sequences. And to do an escape sequence in this language, a lot of languages are very similar. You do a slash. So in this case, I can do a /B for backspace, a /T to tab, /N is a new line. If I want to create if I want to show an actual backslash, I have to do a double one. So there's certain keys that I have to do this in this escape sequence, and it tells the compiler, the language, it says, oh, this is what you're doing this character, and then it does it appropriately. So the slash is the escape sequence, and then it tells you what it's going to do. So we're going to use some of these below in this code, and it's going to be kind of wacky, and you're going to see it's going to give you two different results. And I'm going to tell you why. So system.out.print. So just system.out.print, and then we're going to do quotes. And it's going to do a /T, which so right away you say, oh, that's a tab. And another slash, which is an escape, quote, ABC. Then a // DEF / EGHI /N /NJKL, close quote, right parentheses, and semicolon, and save it. Yes, it's a crazy sequence of characters. So just by looking at this, you try to get an idea of what it's trying to do. So you're in the quote, so it's doing a escape sequence, and it's supposed to tab over, another escape, and then ABC, and then another slash that says a / DEF. Here's another escape sequence, another escape sequence, another escape sequence, and then JKL. So you're going to see this, and we're going to do this here in JGrass, and I'm going to do it another way too, and I'm going to show you. So I'm going to build this, and then I'm going to run it, and you're going to see the output there. Now the book shows, in the book it shows an A, a quote, it shows the quote ABC, DEF. No, I'm sorry, it shows the ABC / DE, no F, and then you get all this in here. And then below you get the JKL. So why is this output different from the other output? You're like, so I'm going to show you what I do. This is another way to, I was talking about different ways to build the programs, okay? So I'm going to go to the command prompt, CMD. This is kind of old school, but you can do it. So you don't need an interface to do any of this stuff. Well, it's not necessarily true, just makes your life easier, okay? Where am I here? What happened? Hold on. CD space, that's the problem. Okay. You can just watch what I'm doing. So I'm in my directory where this program is. I have this program, it's called, what's it called? Data demo or chart demo. I don't expect you to know. There it is. So there's my program. It's called chardemo.java. You'll notice I built it, and so it created the chardemo.class file. This is a command prompt. This is the basic file structure in Windows you can get to. And the way I did it again is I went down here and I just typed CMD. And it shows you command prompt. But we'll talk about this more later. What I want to do is I want to see if I can run this program. I want to run char demo. And to do that, I should just have to type, did I hit insert accidentally? I don't know. Java space char demo. Now you'll notice that's a little bit different than what shows up there, right? So what's here? Here's the rub. this graphical interface cannot interpret characters the same way that this command prompt interface can. So you'll notice that my command prompt interface is identical to the book, for those of you who have a book. Those of you who don't, trust me, it is. It's identical. I can show you the page in the book. Was it 73? Let's see here. 73, 73. I don't want that. I don't want competitive advantages. 73. We're going to run out of time. So right there. So it's supposed to match that. That matches that kind of there, like that. Like that. That's what it's supposed to be. But yet, when you look in JGrasp, it doesn't match that. And that's just something to think about. So if you're ever doing something and you get strange output in a graphical interface, try doing it in the command line, because this command, the graphical can't always interpret characters the same way. Kind of a crazy thing, but that's the way it is. All right, let's see here. For sake of time, we got about 8 minutes. Let's do one more. You've been such a great audience. All right, hang on here. All right, so we're good. We're good there. All right, I want to do. We're gonna do a demo. Because your other assignments, and part of this is just I want to help you say. There's a char demo, is this interactive, this integer demo, but I want to do the scanner class with you just so you know what it is. Okay, so what we're going to do is in 8 minutes, 7 minutes now. Like I said, I can do everything. So what we're going to do is we're going to open up the integer demo we just did before. So if you did the integer demo, which was the last one we did, good thing we did that. So there's the integer demo. So what we're going to do is we're going to change the class name. So the way to do this in Java, the way to just basically copy a class and reuse it, is you can go up to the top and you can just change the name of it. So in this day, I want to call it integer demo interactive. So you first change the name of the class in the class, and then you do a save as, and it'll automatically come up with the new name because you've got a different class in there. Now I've already got it in mind because I did it before, but I'm going to do it. I'm going to save it again. So you change the name of the file in the class, and then you just do file save as, and then it'll then save it as a new thing. So now I have a separate file. I didn't overwrite the other one. That's it. So one thing we're going to want to do is we're going to go to the top and enter, and we're going to import. Before we did an import of like the J option pane, this time we're going to import the scanner class. So import Java, import space java.util.scanner, and that's with a capital S. And don't ask me why they do that. This is our methods, and sometime I'll show you all the different libraries under all these things. These are all different libraries. So this allows us to get input from the user. You can also get at the keyboard level. You can also get user input from the user with the J option pane. One way, display the dialog. Another way is to get input. So we're going to try it. So now what we're going to do is we're going to go inside the main. Go below where you declare variables. Typically, when you declare variables, you declare them all at the top. So we're going to leave that alone. And I'm going to come down here and I'm going to create a scanner class. So scanner is the class, space, and typically I like to use the word input. Input, it's whatever you want, but I like to use the word input. Equals new scanner, and this is all boilerplate, system.in, sorry. We're doing is we are creating a new instance of the scanner class input. So scanner is a class. I cannot use the class directly. I have to create what's called a new instance of that class. And I don't remember if you remember from our last week, we had the dog class, but you had a German Shepherd, a Collie. Those are instances of the main dog class. This is what's going on now. I have a scanner class, and this is an instance of it. Let's see if we can at least create one. Let's just do this one of them. So I'm going to create an output. So I'm going to say system.out.println. First, I got to tell the user what I want. They should just do a print, and they just want to enter. Please enter. So nice. Enter an integer. And they put a little right caret, okay, and then do a space. And what's going to happen is your cursor is going to end up right at that line on the screen, and then the user is going to enter a character. Then what you do is, what we're going to do is we're going to use this variable we used up here, int. I'm just going to use that because we already have it. And I'm going to say int is equal to input. That's just from the scanner class. Input what? Dot next int. And next int is a method of that class. So it's going to get that. I'm going to hit enter. And all I'm going to do is spit out what we just put in there because we're running out of time. And I'm going to say you entered space plus int. Now let's see if I did this okay. So import the Java util scanner. Then we're going to do the scanner input equals new scanner system.ini. We're going to print it out, and this will be the last thing we do. And then we're going to do that. Let's just compile it. Okay, so I didn't do any programming errors. That's good. And now let's run it. Please enter an integer. I'm going to enter an integer that's different than the one in there because I already coded to 12. I want to make sure I use something different, so I'll do 35. And it says you entered 35 along with all the other stuff. So it worked. That is a simple way of getting information from a user. Like I said, what will happen is I had students would create total role-playing games, RPG games, using this interface. They give you a description. You are in a dark cavern. Water is dripping around you. Which way do you go? And they would enter and they type something. So you could do the whole game. And I had students who did a very elaborate game. It was really cool stuff. So, I mean, that's a simple way of doing it, but you can do it like right now that way. Now, there's different things you can do with numbers and all that, but I just wanted to show you.